Guys, Mrs. Bernal here, and today I'm going to be talking to you about finding the surface area of a pyramid. So I want to focus on the definition of what is called a regular pyramid. So I'm going to put that here, and of course it's upside down, so let me flip this over. Okay, so regular pyramid. So if you can pause, right? So you can write this down because I'm going to be talking and then you're writing, and I'm sure I speak faster than you can write. So regular pyramid. So when we say regular pyramid, that's a pyramid whose base is a regular polygon. So a regular polygon is a shape whose sides are all congruent. So if I'm talking about a four-sided polygon, all the sides are congruent, that would be a square. So if I'm talking about a regular four-sided pyramid, or whose base is four sides, we would be talking about a square-based pyramid. Okay, so that's what that means when you see regular pyramid. And then if you have a triangular base, you can assume, and it's a regular pyramid whose base is triangular, that would be an equilateral because all the sides would have to be equal. So that's referring to the base. Okay, so pause and write that down. Okay, so hopefully you're back. We're talking about surface area of a pyramid. So the surface area of a pyramid is just the sum of the areas of the base, right? So imagine a pyramid, it's sitting on its bottom, right? So that's the base. And then the sides that come up, those are the lateral faces. So surface area of a pyramid is simply the sum of the areas of the base, whatever shape that is, plus all the lateral faces. So all those faces that meet up to a point. All right, so go ahead and pause and make sure you have that written down. Okay, next I just want to point to your book. This is in your book. This is a diagram to show you what I'm talking about here. So we have this base. We're talking about regular pyramid. So all the sides of the base are the same length. So you can see it looks like a square. And then the lateral faces, right, are all the faces going around that meet at a point. So this one would have four lateral faces, right, because it's a square-based pyramid, and then we have its base. Now, something called slant height. This is different than the height of the pyramid itself, and that will become important in the next sections when we look at volume. But for the surface area of a pyramid, we need to look at the slant height. So really what we're saying is we're looking at the height of each triangle that is a lateral face, and that height is slanted. So that's why they call that the slant height. So notice you have triangles and you have a square. You know how to find the area of all of these shapes. So once you find the area of each shape, you just have to multiply by the number of times they occur and then add it to this base. Okay, so that is what we are going to do next. So if you want to go ahead and pause, and you could copy this sketch if you would like to. Okay, the next thing we're going to look at is how do we then do this? How do we apply what we know? So when we're looking at an example of a square-based pyramid, again, I didn't have two different colors today. My green and my red ran out. But I have a side length here of 5, okay? And even though it doesn't look like it, this is a regular pyramid. So then this is 5, this is 5, this is 5, this is 5. Okay, now the height of one of the lateral faces is 8. You'll see a right angle because remember, the height of a triangle is really always that height that that's perpendicular to a side. So that's why we have that right angle in there. And if you're wondering where I'm getting this from, this is example 1 on page 364 from your textbook. So the first thing that is helpful to do is draw a net. So we have a square base pyramid, right, whose the edges of the base are 5. And then if we were to open this up, these lateral faces would fall to the sides and would look like that. And each one of them would have a height of 8. This one also would have a height of 8. This one would be 8. and so on. Okay, so and then in this one it was given in 8 inches. So 8 inches, so the units are the same for all of them. Okay, so the next thing we're going to do is we're going to say, okay, well, I can find the area of one triangle, and there are 4 of them, so I'm just going to multiply that by 4. So I'm going to use my area formula for a triangle, and I have 1/2 base times height. So 1/2 base is, remember, this is 5 here and 5 here and 5 here. So area or base is 5. So I'm going to go 5 and then times the height, which is 8. So 1/2 times 5 times 8. Remember, you can do this in any order. You can take 1/2 of 8, which is 4, times 5, which is 20, or you could do these two together, which is 40. Half of that, it's still 20. So the area of one of the triangle faces, which is a lateral face, is 20 inches. Okay, so if there are 4 lateral faces, then you're just going to multiply that by 4, and that is 80 inches. So you have covered finding the area of the lateral faces, right? Those sides that would meet up at a point and would make the sides of the pyramid. So then the last step is to find the area of this base, which is 5 by 5. And again, you know how to find the area of a square, which is just go length times width. So we're going to go 5 times 5, and that is 25. And remember, the definition of finding the surface area of a pyramid is to find the sum of the areas of the base and the lateral faces. So we found these two, so now we just need to take the sum, right? So we just add these two together, and you would get 105. I just got to move the camera just so it can see my work here. All right, 105. Let's see if I can expand my view here so you can see the problem in its entirety. All right, so we started with looking at a very poor 3D image of a pyramid. Sorry about that. And then something to help us would be to draw its net so we can understand better what we're looking at. Find the area of one of the lateral faces, times that by 4. And then find the area of the base, take the sum of those, and you would have 105 inches squared. Okay, so remember, this was the lateral faces, and this was finding the area of the base. Okay, and then you take the sum of those. So this was just one face, one lateral face, and then we times it by 4 because there were 4 of them. Okay. All right. So if you want to, you can pause and finish up copying those notes, and then we're going to look at another example. Okay, now we are on to our second example of how we find the surface area of square-based pyramids. Okay, so, or something we call regular pyramids with a square base. All right, so we have a sketch again. So one side is 6 feet. So since we know that these are regular pyramids, this would be 6 feet. The back and the side, of course, all 6 feet. Now, this height here, that's that slant height of one of the lateral faces or one of the triangular faces is 9 feet. Okay, so remember from our notes, we're going to find the area of the lateral faces first. So the shape of one of the lateral faces is a triangle, so we're going to use area equals 1/2 base times height. So we're going to plug in our base, which is 6, times the height, which is 9. And then when you put that in your calculator, if you can do that mentally, that would be 27. Now, there are 4 of these, 4 lateral faces. So we're going to then multiply that by 4. So that should be 108. And if we're looking at the dimensions, they were given in feet. So we'll make sure to add that at the end. All right, so this is the area total of the lateral faces. All right, now the area of the base ends up being just 6 by 6 because we're going to do length times width. So we have 6 times 6, which is 36. Now, you have to just take the sum of all your faces of your regular pyramid. So we're going to take the area of the base plus the lateral faces, which is 108. And when you add that up, you should get 144. Okay, 144. And it was in feet. So we're going to do feet and then squared because it's area. Okay, so again, all of these, when you look at the net, or if you're looking at just the 3D image here, drawn in 2D, they're all faces, right? But the bottom face has a special name called base. And then those faces that meet up at a point, those are called the lateral faces. Okay. So I believe that Mrs. Chapman is going to be talking to you about finding the surface area of a triangular base pyramid. And we just want to point out too that you can have any shape as a base. So for example, and I'm going to just move the camera over here. If we're looking at number 11 in your book, for example, notice what shape is that? Think about that. What is the base shape? All right, 5 sides. Yeah, it's called a pentagon. The area of the base is already given to you. See how it says area of base is 440.4 millimeters squared? That's already been figured out for you. So you would just have to find the areas of the lateral faces and then add that to the area of the base. And so you would just have to find one triangle. So that would be 16 times 20 times half. And that should be 160, right? And then there are 5 of those triangular faces that meet up a point, because on each side of the pentagon, there is one of these lateral faces meeting up to a point. So then you would just have to take that 160 times 5, and then whatever that product is, add that to 440.4. So if you were to try that, you could pause, and I'm just letting you know that your answer, final answer, would be 1,240.4 if you wanted to give that a try. All right, so if you have questions, remember, just contact your math teacher, and watch this video as many times as you need to. Pause and take notes, rewind, watch again, and hope you guys have a great week. Thanks for watching.